Okay, so now we're going to start talking about measures of dispersion. And we really only have two measures of dispersion that we've talked about. One is the range of my data, and the other is the standard deviation of my data. We're going to use the same three distributions that we used for calculating my measures of central tendency. And so you can compare this to that video. And then depending on how long this is going, I may or may not do a couple of more examples at the end just for standard deviation, because it can give you an idea of the way standard deviation varies based on the distributions. I went ahead and left our mean calculations in place because you have to start a standard deviation calculation with the mean calculation. And since we've already done examples of each of these first three's mean calculation, I'd leave that for the other video. So I just left those calculations in place. All right, so if I'm thinking about the range of my data, the range of my data is the large value, so the largest value, so the x max, minus the x min. And that will let you know how much space, if you will, this data is spread out over. And so if I take this, my maximum value in this case is 50, and my minimum value in this case is 10. And so I have 50 minus 10 equals 40. All of my data points are spread out over a distance of 40. So that's what a range tells me, is it tells me the space over which all of my data points are spread out across. Now, the standard deviation is a little bit more complicated than that. With standard deviation, well, deviation sounds like change, right? Or movement away from. And that's basically what standard deviation is talking about. It's a way of quantifying how far away from the mean, the average value for my sample, how far away from that mean each member of the sample is, or each data value from the sample is. And it's not a terribly pretty function, pretty formula. Not going to lie about that. The formula for standard deviation looks like this. It goes S equals, and we start out by saying the summation from I equals 1 to n, which basically means over all of my data values, I'm going to take each data value and subtract from it the mean. This is called demeaning the data value. And bad joke here, but I don't mean insulting my data value. I mean removing the mean value from my data value, so that the average of this new population, after I subtract all x bar from all of them, that average would be 0. The new sample, not population. Okay, and so it's each demeaned value squared and then added together. Now that gets divided by, that sum gets divided by n minus 1, and then the whole thing, denominator, numerator, all of it, the whole thing gets a square root. And so, teacher with a tablet making this look a little prettier, we end up with that S, my standard deviation, equals all of that. Now, if you've ever heard of the word variance, we won't be using that in this class. But if you've ever heard of variance, it's just S squared. And so variance is just that same formula, just without the square root. Okay, so how do I actually calculate that with this data set? Well, I have my mean value, my x bar of 21.6, and it's going to be the same for each of these. And we call this, by the way, a root sum square for the numerator, because it's the square root of the sum of a bunch of squared values. So RSS, root sum square. It's a very common pattern in mathematics. Now, how do I actually calculate it? Well, I have several copies, but it boils down to 5 different data values, right? And then several copies of those 5 different data values. And so I'm going to have a 10 minus my 21.6 repeating squared is one of my deviations from the mean, but I have 5 of those. So I'm going to multiply that by 5. And I'm going to add to that 3 copies of 20 minus 21.6 repeating squared. Plus, oops, I'm going to run out of space so fast here. Tell you what, let's drop the position of my range calculation and shrink it down just a little bit to get it out of the way here. See if that's gonna buy us enough space to actually make this readable. All right, so I've got 3 of those 20 minus 21.6 repeatings. Now I only have 2 of the 30s, so plus 2 of the 30 minus 21.6 repeating squareds. Plus, now I only have 1 of the 40 minus 21.6 repeating squared. We are very much running out of space here. Not so happy. Erase that. I want this to be somewhat legible. So that's the 21.6 repeating whole thing squared there. And then a little bit more space here at the end. I'm going to have plus and then 50 minus 21.6 squared. And then that whole thing is going to be divided by my 12 data points minus 1. I did promise this was a pretty ugly calculation, right? Okay, so when I go to my calculator to type all that in, I know that it's going to be a numerator divided by a denominator. The denominator is going to be 12 minus, not 21, 12 minus 1. Even I can do that in my head and say that's 11. I'm just writing that out just so that you see where everything came from. Okay, so now I'm going to say this is 5 copies of my 10 minus 21 point, and just put a bunch of 6s in there, and then squared. And then that'll be plus 3 copies of my 20 minus 21.6 with a bunch of copies, a bunch of 6s in there, squared, plus 2 times 30 minus 21 point, bunch of 6s, squared, plus, that was 30, right? If I scroll over, gotta remember, always like to know what I'm typing next. All right, so now I'm going to do the 40, right? So I'm going to have 1, then I'm going to have 40 minus 21 point, bunch of 6s, squared, plus 1 times 50 minus 21 point, bunch of 6s, squared. Then that's divided by my 11, and I hit enter, and I get 178.787. And I look at that and I say, that can't be right. That can't be right at all, because the entire range of this thing is 40. And so 178.7 or 178.8 is nonsense. What in the world have I done? And I would love to pretend like I did this on purpose, but no, I simply forgot to put the square root in. And it just seemed like a good teachable moment and a good thing to keep in. So no, 40 is the entire spread of my data, so my standard deviation cannot be more than that. That's ridiculous. And so I know this number is wrong, so I look back and I say, well, what did I forget? Well, really quickly I see I forgot to put that square root in. So this is actually my variance, not my standard deviation. And so I go up, and I select that, and I close the parentheses on the right side, and then I press the right button so that I jump around to the beginning, and then I hit second and x squared, so I start my square root. Oh, rats. It's going to want that whole thing to be retyped under the square root, huh? Okay, what's a way around that? If your calculator is against you, how do you work that out? Well, another way to write a square root is to raise something to the 1/2 power, right? That's the exact same thing as a square root, a fractional exponent with the denominator is with a denominator of n is the same as a root with a root of n. So a third root or cube root would be to the 1/3. A 10th root would be to the 1/10. And so this is a square root or a second root, and so it's to the 1/2. Okay, and so if I hit enter there, now that makes a lot more sense. 13.3 makes a lot more sense as far as spreading that data around the mean. That actually seems like a reasonable answer, something that's not nonsense, and so I can accept that answer. And that's what I mean by not turning your brain off and always running a gut check on your data, because it really just saved me a very embarrassing mistake. All right, so that's my standard deviation for that data set. Okay, let's do the same calculation, or the same pair of calculations for this next thing using our frequency polygon here. Now, if I want to find my range, again, that one was relatively straightforward, so we'll do my range first. And that was just my x max minus my x min. Well, my largest data value here is a 15. My smallest data value there is a 10. And so that's going to be 15 minus 10 is 5. And so my range equals 5. And that basically means that all of the data that I have is spread out over a value of 5. Okay, now, how do I calculate that standard deviation? Well, the standard deviation is the summation for all data values, I equals 1 to n, of each data value minus the mean squared, divided by the number of data values minus 1, and then square root of that whole thing. Okay. And so my n minus 1 is going to be 13 this time, right? Because I know that my n was 14. That was something that I had calculated before in the earlier video. And I know that my x bar, my mean for this, is 12.43. And so if I use those values, I can go ahead and calculate the standard deviation. So I have 10 minus my 12.43 squared is one of my deviations, right? Because there's 10 is one of my data values. But I have 2 of those data values, and so I multiply that by 2. All right, so that's going to be plus, and then so I have another 2 of those data values. And so what am I going to do? I'm going to take 2 times 11 minus 12.43 and square that, plus, and this time I'm going to have 3 of my data values times 12. It'll be 3 times 12 minus 12.43 squared. Okay, and then I'm going to have 4 at 13. That'll be plus 4 times 13 minus 12.43 squared. We're getting there, just 2 more to go, right? So I have 1 times 14, so 14 minus 12.43 squared. Uh-oh, running out of space. Running out of space enough, I'm going to have to shrink this down just a little bit. Try to not make it so small it's not at all readable. And then plus, and this time I have 2 of the 15, so 15 minus, gotta keep making it smaller. Keep making it smaller and shifting it over. And I have 12.43 squared on that whole thing, divided by, and that's going to be 14 minus 1. Okay, quite a lot to type in. Wait, what did I do? I never fixed this over here. I got the square root of all that and the square root of that, right? And so the square root of all that over the square root of that Sorry, my tablet's decided it doesn't want to scroll right now, so I have to use 2 fingers to scroll up and down, which also zooms for some reason. All right, well, let's do this calculation. This time I'm going to put the second and square root on this from the beginning. And I'm going to say form-wise, I know this is a numerator divided by a denominator, and the denominator is 14 minus 1. Okay, and so now in the numerator, I'm going to have 2 times, parentheses, 10 minus 12.43 squared, and then plus 2 times 11 minus 12.43 squared, plus 3 times 12 minus 12.43 squared, plus 4 times 13 minus 12.43 squared, plus, so that was 13, I got 14 and 15, well there was only one 14, and so that's just going to be 14 minus 12.43 squared, plus there were 2 15s, so I have 2 times my 15 minus 12.43 squared. And that's my entire numerator divided by 13, and then that whole thing's under a square root. If I hit enter, I get 1.603, which if I look at my data spread of 5, that actually seems reasonable. If I look at the peak is in the center, it's more tightly clustered in the center than it is out toward the edges. And so that does seem like a reasonable answer. S equals 1.604 as far as my standard deviation goes. All right, let's take a look at one more. This is taking long enough. We won't do the last 2 examples with the other distributions, because they're both histograms anyway, so it'll be kind of repeating the first example, very similar to repeating the first example. All right, so if I'm thinking range of this, I'm going to look for the smallest value. Well, that's going to be the smallest stem, and the smallest value off the smallest stem. Well, there's only one value on the smallest stem, so there's not a lot to choose from. I have 28 for my x min, and range was x max minus x min. And so I have my 28 for my x min, and then what would be my x max? It'll be the largest leaf off the largest stem. And so that's going to be a 47, right? A 47. And so my range is going to be 47 minus 28. Hopefully that's 19. 47 minus 28. Hey, what do you know? That's 19. 19. All right. Go ahead and erase those so that we can mark up as we're calculating our standard deviation. All right, well, since we can still see the standard deviation equation up here, I don't really feel the need to rewrite the whole equation again, but I do need to figure out how to actually do the calculation, right? In this case, I don't have a lot of repeat values. In fact, I only have 1 pair of repeated values here, and that'll be my 234s in the middle. Everything else is going to be unique value, which is going to be a pain in the neck to write down and calculate here, because this is a relatively large data set to do by hand. All right, so I'm going to zoom in a little bit here so I can write a little bit smaller, and we'll go ahead and switch back to purple. So what do I have? I'm going to have my 28, there's only one of them, minus my median, 37.7 repeating, squared, plus my 32 minus 37.7 repeating, squared, plus my 34, but there's 2 of those, so plus 2 times 34 minus 37.7 squared, and then plus 39 minus 37.7 squared. All right, now we're going to have 40, 41, 50, and 40, 45, and 47. So So plus 40 minus 37.7 squared, then 41. Then 45 and 47, but we run out of space, so I'm going to cheat a little bit, and I'm going to write them underneath here. So plus 45 minus 37.7 squared plus 47 minus 37.7 squared. Okay. That's not pretty, but it is done. We have written it down. And so then we're going to be over 9 minus 1, and then square root of that whole thing. Okay, well, let's go start typing over here. I've got the square root, and I've got a numerator divided by a denominator. The denominator is 9 minus 1, 8. You know, we can do that in our heads, but I'll still write it down just so you see where the numbers are coming from. Now I'm going to have a bunch of unique numbers this time, so I won't have coefficients out in front of there because there's one copy of each number. So I have 28 minus my 37.7 repeating, so I'm going to put a few sevens in there, and then square that, plus 32 minus 37.7 squared, plus, and this is the one where I do have some repetition, because in 34 I had 2 copies of this 34 number. So I have 2 times, and then 34 minus 37.7 squared, plus 39 minus 37.7. Oops. What have I done? I forgot to put the parentheses on that, which is a big deal. Otherwise, it doesn't actually square the whole result. It just squares one number. Okay, and then plus, put the parentheses in this time so that I'm not wrong like last time, and do 40, not 10, minus 37 point bunch of sevens squared, plus 41 minus 37 point bunch of sevens squared, plus, you get the idea, this can get tedious quickly, 45 minus 37 point bunch of sevens, oops, tedious until you typo something, 37 point bunch of sevens squared. What did I do? Did I forget to put that parenthesis in? No. So why do you not have a closed parenthesis there? Did I accidentally delete it? Must have. I'll go back and check in a minute. All right, so that was 45. Now I need 47. So plus parentheses 47 minus 37 point bunch of sevens. And then I cried because I hit clear. All right, I will accelerate this when it comes to actually time to post this to YouTube. Let's just type all that in again. Square root 28 minus 37.7 squared plus 32 minus 37 point bunch of sevens. Oops. Point bunch of sevens squared plus 2 times 34 minus 37 point bunch of sevens squared plus, that's a squared, not a 2, squared plus, that was 34, so now I got to do 39. 39 minus 37 point bunch of sevens squared plus 40 minus 37 point bunch of sevens squared plus 45 minus 7 point bunch of sevens squared plus 47 minus 37 point bunch of sevens squared, and what do you know, I forgot, or got eaten up along the way, to put the parentheses around the entire numerator. Then divide by my 9 minus 1, which is 8. I do like to cycle through, so I've got 2 open, I've got 1 open, I've got 2 open, I've got 1 open, I've got 2 open, got 1 open, 2 open, 1 open, 2 open, 1 open, 2 open, 1 open, 2 open, 1 open, 0 open, 1 open, 0 open, and we're done. Okay. It's a good way to check for balance, to see if your problems are balanced there. All right, now, my standard deviation here is larger, but if you also look, my range is larger, and if you look at those data values, they're spread out more, so it actually makes sense that my standard deviation is larger in this case. So S equals 6.14 seems like a reasonable answer to go with. All right. Sorry about the tedious calculator typing there. This is definitely a longer method, and I definitely can't give you a very large data set on the final to calculate the standard deviation from. But based on what we've done in class, I can basically promise you that there'll be at least one place where you have to calculate the standard deviation. Shouldn't be a surprise, because it's probably the most complicated thing that we've done in this chapter. So it'll definitely be there. I can't give you too large of a data set, or you end up with just too much tedious writing down and calculator typing. And I'm not really after tedious work. I'm after thinking through and getting the process right. So make sure you get your process right, and if you forget it, tell me what you remember. Hope this helps, and good luck studying for your finals.